Alright, so let's start our chapter 2. Come on, class. First order linear differential equations. Okay, for your syllabus you will only learn for first order. Okay, you will not go to second order or third order. That is another syllabus. So thank God, Alhamdulillah, you're still alive. And don't worry, first order is easy. Let's begin. Okay, first and foremost, if I give you something like this, y equals to, let's say x cubed over 3 plus 11 over 3, and I want you to differentiate this. What do we get? dy dx x squared. Is that right? But now if I ask you integrate this, what do you get? Integrate. I mean, we got ourselves y equals to x cubed plus x cubed over 3 plus c. Okay, we know differentiation and integration are reverse process of each other. Bless you, Yarhamukallah. It's a reverse process of each other. But there's still one more value that we did not get. 11 plus 3, 11 over 3, which is in this case is plus c. Okay, sometimes this is what we call general solution, okay? With the plus c is called general solutions. If the question said, okay, given if x equals to 1, y equals to 4, sometimes you will have this extra information. So what do you do with this? You plug in the number back. So you got yourself 4 equals to 1 over 3. So, okay, thank you, sorry. Plus c. So that makes c is equals to what? 11 over 3, I guess. And where should you put this value in? To your plus c, okay? So you got here y equals to x cubed over 3 plus 11 over 3. Okay, if you got this value in, no more plus c after you have substitute this value. This is what we call particular solution. So, do you remember that whenever I ask, okay, don't forget about plus c, this is why it's very important for you to have plus c, for you to get the particular solution. Okay, in chapter 1 we don't use it that much, but in chapter 2, if you forget to do this plus c, most likely you will lose around 7 to 8 marks. Okay, so be very careful, because to find particular solution you need that plus c. So let's begin. So this is simple, sir. Alright, introduction. Okay, what I did just now is Not entirely correct. What I mean by that is when I'm integrating things up. Let's say you are given something like this. This is what we call separable variable. Okay, so let's say you got dy dx. You will have two things here. One is x. Another one is y. Here we have two things. Okay, and someone said, sir, 2 is constant, sir. Well, I prefer my constant to stay with x. Constant together with x, combined with x. You ready? What happened here now, we're going to separate them up. So 1 over y remain here and 2x remain there. Here's dy, right? So what dy stucks here. Here's your dx. Your dx goes there. This method is not entirely mathematically true, but just to make it's a shortcut for your maths. Normally dy dx, they cannot separate themselves. You hear? So this is what we do. We separate them. As you can see, only y, only x plus constant. You okay? And once we separate, we also integrate. Integrate 1 over y, ln y. Integrate to x, x squared over 2, but hey, 2 here, cancel off. Are we done? Where? X or y? X or y? Or x o s o? Yeah, well, interesting is well, it can mean hard and cases, right? But in American football, it means attacker, defender. Well, detour. Okay, where should we put our plus C? Left or right? Technically, it appears both. Yes, you are right. Technically. But we combine them up. Okay, we bring this plus C, we put it aside. So we can say C1 plus C2 becomes C3 maybe lah, okay. So you can skip this process and straight away write down ln y equals to x squared plus C. You may skip this process, okay. I just tell you why we got here lah. Basically what happened was C2 minus C1, so becomes C3, which is we just write down C. Okay? Once we reach here, there are many ways to continue. We want our y to be alone. But right now there's ln. How do we make ln disappear? The exponent both sides. So here become y. What happened here to the right side? Exponent what? Exponent x squared. Where is plus C? Down or power? Down or power up? Power up. Everything got power up. Anybody here play Mario? You take mushroom to power up, right? Okay, here's the thing. When I do this, a small note for you, 2 squared plus 3, I can also rewrite as what? All of these are power up. Yeah, 2, 5, or I can separate them, becomes 2 squared, 2, 3. You okay with this? I can split them up like that, okay? So what happened here is EX plus C becomes EX squared times EC. You okay? Okay, EC, is this, are there any variables here? Are there any variables? E is what? Exponent, yeah, is a constant. C is a constant. So both of them are constant. Since both of them are constant, we can rewrite them as, yes, you can do C, but mathematicians prefer to put another letter there. AEX squared. So these things becomes A. So, and normally we put things in front. Okay, so constant and constant becomes new constant. Are you okay that far? You just need to memorize the steps. Don't worry, we'll go through them again. Alright? You may skip these steps if you can. Just go straight away to down here. It's understandable. And then from here, we are done. It depends on the questions. This is how we separate things up. Okay, so what do we do over here? Tell me again. Let us revise them. This is easy. So I see myself dy dx, and I see constant plus x, or x plus constant, and I see y, and then what do I do with it? I separate them up. I bring my y to one side. I bring my x and constant on one side. Once I reach here, what do? I integrate them up, and I integrate as usual, and I got my plus c over here. Why are we not yet done at these steps? Because there's a ln, and I want my y to be alone. Okay, so how do I make the ln disappear? I exponent. Okay, when I exponent, x squared and c, they got power up. They got power up, they got also up. And then what happened to our c? EC, which is also a constant. And what do we do with it? We transform as A. Why do we choose A, sir? Well, you can choose any letter that you like. Let's say my name is Rodi, I can put R. But it just sounds weird in exams. Okay, so they just put A. Okay, so let's try one more time. This one is a bit tough. Okay, another example for you. dy dx equals to y squared e negative 2x. Okay, what can you see? Tell me. I see this is y, and I see this is x. What do I do with it? I separate them up. So I got 1 over y squared here. I got e negative 2x there. And what should I write here? dy dx? dy, and here is the x. Are we done? What should I do? I integrate them up. You separate and integrate. You guys okay? And how do I continue from here? Well, you got integration sign, so what should I do? Integrate. So 1 over y squared integrate. This is, yes, right, bring it up. So y negative 2. Integrate 1 negative 2. So I can write it down something like this. Y negative down. Okay, the negative stays there. Integrating the right side. E negative 2x. Copy them first, don't make your life hard. Over negative 2, I'm fine with it. Or 2 and negative over here. Okay, anything, I'm fine with it. Are we done? Where should I put my plus C? Well, technically it appears both sides. But what happened next? Move to one side. So we can make our life a lot shorter and easier. You are allowed to just put plus C on the right side. You okay? Okay, cool. So are we done? Why not? Why not? I want to make the y alone. This is not alone. Yes, but it combines to one side. Yes, the plus C is here. They are both sides. Then what do we do with it? Yes, C2 minus C1, so it combines to one side. Okay? The reason why I do this is not because I want to show you can combine. So I'm combining them to one side straight away, makes our life shorter and easier. I think that's a bit I said it wrongly, make our life shorter, make our problem shorter. I don't want my life to be shorter. I want to live longer. Okay, what should I do? How? We take the negative out first because that's the easiest thing to do. So 1 over y. E power negative or even power negative positive? Well, only this one become positive. Well, the minus C, I'm a bit reluctant because C is okay, because C can be negative as well. Okay, now what? Do I want my answers to be 1 over y? I want it to be y. So technically I want to flip them up. But this thing here, they are not cooperating well. So because this one is a fraction, this one is not a fraction, so what should we do? Equalize the denominator, make it into one big fraction. So e negative 2x minus 2c over 2, 1 over y. Oh yeah, so what should we do now? We flip them up. So what do we get? Y 2 e negative 2x minus 2c. That's okay as your final answer. Technically, I don't really like it because the negative is down there. That's what's shown in the lecture slide. Let's not waste too much time and move on to the next example. You guys okay? Can you see what do we do? We got y, we got x. What do we do then? Oh yeah, I forgot to say one thing. The y and x are times. You see this relationship? They are? It can be times or divide, okay? Same goes for here. These two things here are either times or divide. Hopefully you can see one good example of divide. I'm sorry, not listed here. So we see y and we see x, they are times or divide, and then what do? We separate and then we also integrate, and then we integrate the value. Then what do? Why are we not stop here? We plus c here. Then why are we not stopping here? Because we want our y to be alone and just rearranging them out. Okay? Cool? Very good, very good. And now, let's try this. Okay, that's the question. So how do we start? Well, I see here, that's my x. I'll see here, that's my x. Did I see my y? Y is not there, sir. Y is not there. Okay, I'm fine with it. I don't have my y, but I have my x over here. What should I do with this x? Bring it to one side. So it becomes x square root 1 plus x squared dy. I don't want my dx over here. I want my x all to go to one side. So I got my dx over here. Technically, what do I do? What did I do at these steps? I separate them just now. And someone said, sir, where's the y, sir? There's no y, sir. I mean, y is 1 over here. I mean, here is 1. Are you okay with it? So what do I do now? Integrate. Very good, very good. Integrate the left side. What do you get? Y. That's good. What? How do we integrate the right hand side? How? By parts. Why by parts? Okay, just before we continue, when do we use by parts? Two different types. This is poly, this is poly. Square root is considered as poly. If we see square root, what do we do? Substitution, where you let what? U equals to 1 plus x squared square root. Okay, I'm not teaching you substitution here because we have done that drill quite a lot of times. And you want to know why I trained you so much for chapter 1? Because we are going to meet them again over here. Okay, so that's why I keep on saying be good in your substitution, be good in your by parts, be good in your partial and everything. Okay. Spoiler alert, we're going straight to the answer. If we do that one, we're going to get this one here, okay? 3 over 2 over 3 plus c. If we solve them lah, which I'm skipping them. Are we done? As this is our final answers. Why not? There's a plus c there, not a problem. You need to substitute this value here. This is what we did in our first thing just now, okay? You remember on our first thing that we did today? How do we got this c as 11 over 3? You substitute x1, y4, right? It's given. Okay, are we given any value? x0, y0. So where should we substitute this? Over there. This two for sure. So 0, 0, 1 plus over 3, 3 over 2 plus c. So that means what's my c? C is negative 1 over 3. Are you guys okay? Still alive? Not dead? Very, very good. Are we done as this is our final answers? Why not? You need to sub back. So you got yourself y equals to 1 plus x squared over 3, 3 over 2, minus 1 over 3. This is okay, or let's say you're a bit more kiasu, you may write down this way. Both of them are okay. By the way, to the internet viewers, kiasu means, what does kiasu means? They're always trying to be better than someone else by small tiny little things. Sometimes a bit annoying. Okay, one more example before we move on. 1 over x dy dx y squared cos x. Okay, this one is tough. Y pi equals to 1. Y bracket pi equals to 1. Okay, before we go further, what does this mean? It's like this. It's like fx equals to something, right? So we put the value, we got something. So from here, we can say x is pi and y is 1. Okay, look very carefully here, class. Don't get this thing confused again in your life. I'm repeating myself again. Don't get yourself confused with this thing. It's like fx. So x is pi. Right, so we got here. How do we start? I see here's my x. I see here's my x. And I see here's my y. So what do? We separate them up. So we got ourselves 1 over y squared dy. What's on our right? X cos x or cos x squared? Cos x only. Dx. Are we done? What should we do? Integrate. Integrate the left side. We have done something similar just now. Negative 1 over y. The right side, how do we integrate? By parts y. Two types, two different types. So it's by parts. Okay, I'm not going to do by parts with you right now. It's going to take quite a long time. Just going to go straight away to the spoiler alert. Y equals to okay, I don't have that one. I got here. And then we want to substitute. Substitute what, sir? This value, how do we substitute this inside here? So y is 1. So x is? X is pi. Sine pi plus cos pi. Sorry. Plus c. Okay, there's one class that I have explained. The left side is negative 1. Pi, please remain as pi. I think that's the best. Don't press your calculator, just make things messier. Sin pi, however, is equals to what? If you want to press this in your calculator, make sure it's in radian mode. How many people have made that mistakes? Make sure it's in radian mode. Or if you don't want radian mode, what do you do? How do you do in degrees? Sine 180. Another one is cos 180. Don't make that silly mistakes. Sine 180 or sine pi, how much? 0. Cos pi? Are you sure? 1? -1. How do you know, sir? How do you know you got it wrong? Because I memorized the graph. I remember this is sine graph. And I remember this is cos graph. Where's the pi? Oh, 180. This is 180. This is 180. That's why I remember just now sine pi is 0. That's why I remember as well cos pi is -1. Okay, that one is simple. You just need to memorize a few things. Yes? Come again? Yeah, this can become -1. Come again? Are you okay? Are you okay? Singlekan y, what do you mean? Oh, we are not yet done. We are not yet done. So from here we got ourselves, oh, C is 0. This thing is 0, this thing is 0. So C is 0. So you got this one back. Plus 0 means nothing. So y is equals to -1 x sin x plus cos x. This is okay. Yes, I kind of understand your question just now. Wait to the online. Your question just now is like, should we not make y alone first before we substitute the values in? It depends. Sometimes it's easier to substitute first and sometimes it's easier to substitute later. But I kind of have to agree with you. Most of the time it's easier to substitute later. Most of the time it's easier once you get your y alone, then only you substitute. And that's kind of better as well because it can avoid the careless mistakes. People forgot to rearrange things back. But I'm following the syllabus provided here. You okay? Right, so we're moving on to the next one. So that's your separable. Easy. Boom boom pow.